Hello, everyone. I think we are live. Wonderful. Let's see if we are live. Let's. Yes, I see the chats ramping up. Hello, everyone. That's great to be here. Let's maybe wait if we are 32 online. Let's wait a few seconds and let's kick off this great session, our first and incredible session. Three. Wow, I see a few names that we know on the chat. Hi, everyone. Good to see you. Wonderful. Okay. Okay. Hey, George. I see Aurélien as well. Hi, everyone. Oh, that's great. Okay, so maybe let's start. People will join during the session. So hi everyone and welcome. Well, we are super happy to have this session and super happy to launch actually it's our first webinar as Pianot AI, and we are super happy to be showcasing what we launched earlier in September, and as well we are super happy to have you with us, VB, and we'll hand you the mic in a few seconds. Maybe before we start, a quick word about the format. So we are on Livestorm, so you can use the question tab to submit your question at any time. We will have a two-part session, so we will have Q&A at the end, and happy to answer all your questions. Don't worry, don't take notes. You will receive the replay after the session, and it will be like always. Maybe a few words on us. So Pianot AI, the company that's a bit over 1.5 years old now, but it's a continuity of what you've been doing, Hervé, on the open source side. So super happy to see that we are continuing to move forward on the open source part, and as well with the commercial models. And everything growing very fast, and we're super happy to see that. Let's dive in and let's see how diarization works and how the community one new model is actually bringing a new standard on the side. Maybe just before we start, let a few words on our guest here. Please, VB, could you please introduce yourself, and after Hervé, I'll hand you the mic.
Sure. First of all, thank you so much for having me here. I'm VB. I head the developer experience and community at Hugging Face. Most of my career at Hugging Face has been centered around open source and essentially making sure that startups, which are essentially building on open core philosophy and trying to make sure that all the benefits of core research like Pianot has been doing with their speaker diarization models and so on continues to flourish. I actually used Pianot models before even joining Hugging Face, and I still remember opening an issue and responding on it, with oh, like, have you tried this? Maybe you can try that, and so on. So I have a very warm space for Pianot in my heart and in my career so far. Looking forward to the chat. Yeah.
Great. Thanks, Vivi. I remember the exchange that we had a while back. That's great to have you back here. So I'm Hervé. I'm the co-founder and chief science officer at Pianot AI. You'll know a bit more about me in the presentation because I'll say a few more words about me. So the plan here is basically to start with a short description of what speaker diarization is. I'm pretty sure most of you already know that, and the use cases that we see a lot among open source users. Then a quick story about how we went from Pianot to actually the company Pianot AI. And then I'll dive, I guess, in what most of you are looking for, basically Community One, our new speaker diarization model, and Pianot Audio 4.0, the latest version of the toolkit. Then I'll do a quick demo of Community One and the new features, and then we'll actually spend some time chatting with VB before we answer all of your questions. Let's go. So what is speaker diarization? So once again, you probably already know all of this, but speaker diarization is the task of answering the question, who speaks when in a conversation like the one that we are having. So basically starting from a recording of a conversation, the first thing that one can do is basically voice activity detection. So it consists in detecting speech regions and rejecting non-speech or noise regions. And within those long speech regions, there might actually be multiple speakers. So we need to actually segment those long speech regions. So this is really the role of what we call segmentation. It includes both speaker change detection as well as crosstalk detection. For instance, here you see that there's probably at least two people in these speech regions because that one is interrupting that speakers. Here, it's probably some kind of back channel where someone says, while another one is speaking. So this is crosstalk and speaker change detection. And then once we have segmented the audio into segments, speaker diarization, what speaker diarization really does is assigning a color to each segment, a speaker to each segment. And so here it would have detected two speakers. And the tricky part here is really that we have no prior knowledge usually on the number of speakers, nor anything about their identity. We have to be to generalize to speakers that were never heard before. And that makes actually the speaker diarization task a bit trickier than other classical supervised classification tasks in machine learning. So we've seen lots of use cases for speaker diarization among our open source users. Here, I just focus on a few of them. I think the most prominent one. The first one is, sorry, video translation or automatic video dubbing. Basically, you'd start with some kind of commercial documents or commercial videos in one particular language, and you actually want to touch a larger audience. Then one way is to do automatic translation in another language. And for the translated video to actually sound right to the ear of the French people or the Italian people, it's probably better to use the right two different voice from two different speakers and make sure that the same speaker actually has the same translated voice over the course of the recording. So that's where speaker diarization is actually pretty useful. Another use case is for indexing large audiovisual archives, like podcasts, for instance. You can use speaker diarization to actually track the hosts and the guests across episodes of podcasts. One also very common use case, you probably joined Zoom calls where there are plenty of those meeting note takers joining as well. Speaker diarization is really useful for that. And in particular, when in the case of hybrid meetings where multiple people are joining from the same place. Another use case where getting speakers wrong is might have very bad consequences is when transcribing doctor-patient consultations towards generating automatically SOAP notes. SOAP notes are the forms that doctors, I think in the US, have to fill after each consultation, making the list of all the things that were said and decided by the doctor and given by the patient. If you get basically, so how those scribes would work usually is that you would start with a speech to text, starting from the recording or consultation, and then you would use an LLM to fill this form. And if you get the actual speakers wrong, if you think that's the doctor who asked about the medicine while it was the patient, you can imagine the weird consequences that it might have. And many other use cases, like call centers, obviously, accessibility and education, legal and compliance, all this kind of stuff might be very keen on using speaker diarization as part of the whole pipeline here, and usually at the very beginning of the pipeline. This slide is about how we went from Pianot. I'll tell a bit about the history of Pianot, the open source toolkit, and now the company. So it all started with me joining as a researcher the French National Research Center, CNRS, in 2008, right after my PhD. At that time, I was working on audiovisual document indexing, and naturally, I stumbled across the speaker diarization task. And I really fell in love with this scientific problem because, as you may know, it's a very difficult one, very tricky, very scientifically, challenging. And so I started working in 2012 on this and never really looked back. So it's been almost, it's been 13 years, me focusing almost exclusively on this problem. And at that time, there were also the deep learning revolution. And so naturally, I started playing with neural nets at that time and trained my first neural network to do speaker change detection there. And as a CNRS researcher, my mission was to actually make my research accessible to everyone. And my way of doing it has been to create the open source toolkit, Pianot Audio. And this is the GitHub star history of the open source toolkit. Basically, every time I made a new discovery, wrote a new papers, I would also include the code into the library, and it actually became quite popular over the years. And in particular, around October 2022, when Whisper came out. So Whisper is the speech-to-text open source transcription model from OpenAI. It was really a revolution on the STT part because it was very efficient. Yet it provided words, but not the actual speaker labels. So people actually turned to the most popular speaker diarization toolkit at that time to actually combine the both, and that was Pianot. So all of this really made me think and led me to actually create Pianot AI, the company around Pianot Audio open source with Vincent, early 2024. We released our first commercial model mid-2024 without making much publicity at the time. And all of this led to actually us raising some seed money with our investors, Crane and Serena. And this allowed us to actually go a bit faster and train larger model. And that led to our new the new version of our flagship speaker diarization called Precision 2. And on our way here, from Precision 1 to Precision 2, we actually learned a lot. And how to train better model, how to make them to train larger scale, how to train them faster. And since open source is really in the DNA from the beginning of the Pianot company, we decided to actually contribute those improvements to Pianot open source and continue doing that in the future. So 4.0 is really the result of this, all our work and improving our models. And at the same time as we released a new version of Pianot Audio Toolkit, we also released a much better speaker diarization model that we called Community One. And that's nice that VBA is here because I can then brag about us being the 9 most downloaded models on Hugging Face. Apparently, the models have been downloaded more than 1 billion times since they are on Hugging Face. And you can see the trend is going really up. This is the number of unique Hugging Face users registered to access the pre-trained model. And you see that Community One is off to a good start as well. First, I'd like to talk a bit more about what we actually backported from what we learned from everything we did when training Precision 2 and how we integrate it into the toolkit. So this is just one big slide with lots of things to read, but mostly I'll go over them, but very quickly. So the first thing is we improved accuracy, and this is really the point of Community One model that I'll describe right after. So I won't spend much more time here. So one major work that we did is really on the training part. So this is really targeted towards power user of Pianote Audio who fine-tune their model, train their own models, and we made the training way faster, and also added a new neural architecture. And we are also looking at users who, quality of life improvement. Like we have this new CLI that allows to very efficiently download models from Hugging Face and then optimize or benchmark pipelines. As well as one pain point that we received a lot in the past is that it was difficult to kind of run the open source models completely offline, and we made that easier as well to self-host. And obviously the usual packaging improvement. We now switch to the UV package manager because it's so much faster than pip that we didn't want to miss the bandwagon here. So that's here quickly for Pianote Audio 4.0. Many more improvement, but most of them are in actually, you can see them when you play with Community One pre-trained model. So I'm going to spend more time on this particular new model. So when designing this new model, we actually focused on two pain points that we got a lot from open source users. The first one is basically on accuracy, and accuracy of the speaker assignment and counting part in particular. We would get some feedback saying that, oh, the 3.1 pipeline tends to create more speakers than there actually are, or the other way around, it will actually merge two speakers into one. So we really worked on that to improve that particular part. So a few numbers. We ran on a lot of benchmark. You'll see that in the next slide. But on this particular benchmark that I love because it's quite large, lots of different conditions and different domains. We can really see if we improve on diehard, it means that we are doing a good job. So speaker counting accuracy in particular. So what I mean by speaker counting is really predicting the exact number of speakers. Before we would only predict the exact number of speakers 61% of the time, and now with Community One, we jump to 75%. And even for those cases where we're wrong, the average error between the actual number and the predicted number is less than 1. So we are never very far from the actual number of speakers. And we can also see this from another angle, like the duration of speech that we correctly assign to the right speaker. And there, when switching from 3.1 to Community One, we get an improvement of 16% with respect to this metric. So really a major improvement on this part. And as you can see on all those benchmark, we systematically improve. So those are different benchmarks that I'll be able to discuss if you want during the Q&A. But what you really need to know is that here, the lower, the better, because that's an error rate. And it's basically those metrics are a compound of 3 types of errors that diarization system can make. False alarm. False alarm is when we say that there is speech, well, actually there was no speech, probably because of noise or something. Misdetection is the other way around, where we miss some speaker or we miss some overlapping speaker. That's the most common case of misdetection. And speaker confusion, which was really the focus of Community One, where we actually get the speaker wrong. So this is the sum of the 3 errors. So as you see, we improve almost everywhere. And the second pain point that we got a lot from our users is about speaker attributed ASR. Basically, one of the main use cases for speaker diarization is definitely combining it with Whisper, with Parakit, basically speech-to-text model. And the thing is, we got this nice and bad feedback at the same time, in the sense that Pianote timestamps are actually much more precise than Whisper. And Pianot detects overlapping speech, while Whisper does not transcribe them. So we end up with this kind of situation, for instance, where in this example, there are two speakers talking to each other, and speaker two interrupts speaker one. And Whisper would actually not transcribe the end of the speech here. So you would get Pianot AI timestamps are great. You should. That's what everybody says indeed. And then just looking at that, you end up with those two words. That's what. And you actually don't know whether to assign them to speaker one or to speaker two. And we thought a lot about this problem. And so that's what the exclusive mode is about. By exclusive, we mean that we cannot have two speakers active at the same time. So when you activate this flag, you end up with this kind of diarization. So there's no longer any overlapping speech in our output. And we also make sure that the most likely speaker to have pronounced the words that were transcribed is the one that is active. So it's now much easier to actually align transcription with diarization. And you end up with Pianot AI timestamps are great, you should, spoken by speaker one. And that's what everybody says indeed, spoken by speaker two. And we already got some nice feedback on this feature, and I think it would be really helpful. So I will demo those two new features, better accuracy and exclusive mode now. So let me share my screen. Okay. So there we go. I am now in a notebook that I prepared for the webinar. It will be available to all of you a few hours or days, I don't know, after this webinar. So basically, we are going to work on the sample file that is shipped by Pianot Audio. It's a conversation between two women over the phone. Let me play a few seconds so that you get an idea of what they're talking about.
Hello?
Hello.
Oh, hello. I didn't know you were there.
Neither did I.
Okay, I thought, I heard a beep. This is Diane in New Jersey.
And I'm Sheila.
Okay, so what we see here is that this is actually the ideal diarization that we would like our system to do. It's not an actual prediction, it's really the reference manual annotation. And you see that they are overlapping speech regions between the two ladies, and they are actually interacting quite fast at some point. And so let's see how you can actually perform speaker diarization with Community One. So the first step is to actually create, an access token on Hugging Face and to request access to the Community One pipeline. It's automatic, you get access automatically. And on my side, I've already put the Hugging Face token in an environment variable. So I load it here. And then with this line of code, what I'm doing actually is like I'm downloading the pre-trained model, that pre-trained model from Hugging Face using my token. And now it's in the Community One variable. And then the next step is to actually process the file by basically giving it the path to an audio file. So right now, it's running on my Mac Mini on CPU. And so it's usually taking around 12 to 13 seconds to process a 30-second file. So that's kind of slow, obviously. So obviously, since it's PyTorch behind the scene, we can actually switch to faster backends. So since I'm on a Mac here, I'm sending the pipeline to the MPS device. But if you're on an NVIDIA GPU, you can obviously use CUDA here. And once it's done, I'm just rerunning it, and you see it's way, way faster. It took 1 second to process the 30 seconds. And then we can simply iterate over the speaker diarization attribute of the output to get the actual diarization. So you get start time, end time, and the actual speaker. And so I talked about two major improvements that we made. The first one was about speaker assignment and speaker counting. So here I'm preloading the prediction that the 3.1 was giving. And now we can actually compare the outputs between the two. So this is still the reference. This is the target. This is what we had before, and this is what you can get now with Community One. And as you can see, Legacy 3.1 got the wrong number of speakers, and Community One got it right. The second improvement was about exclusive speaker diarization. So now, while before we only outputted speaker diarization, now we output both speaker diarization and exclusive speaker diarization. And here there is a comparison between the two outputs. So you see that we remove the overlapping speech region. Let me zoom in here. And we make sure that we cut at a particular position where it makes more sense for the transcription. Let me play the audio, the end of the audio here.
Be a Yankee down here, so what can I
Oh,
say?
I don't hear that in New Jersey now.
So you see the second lady actually speaks much louder on this part than the blue one. So that's most likely that we will get the word transcribed for her and not for her. So that's why we actually cut it here. So we hope that this feature will really make the alignment between the two much easier. And a nice addition as well to Pianote Audio 4.0 is that you can easily switch to Community One hosted on Pianote AI API simply by creating an API key on Pianote AI dashboard. You'll get automatically free credits to play with. And then the only thing that you need to change is you add -cloud here, and you instead of the Hugging Face token, you use the API key you created on Pianote. And then you can run it exactly the same way, except now it's running on the cloud. So what's happening here is that we upload the audio to our server, we run it on our server, and then we got the result back. And if we check, we compare with the local output and the cloud output, they're identical. And obviously, you can easily switch as well to our flagship Precision 2 model. In the same way, you select the Precision 2 pipeline, and then you run it. So right now, the same happens. We send the audio to the cloud, we process with Precision 2, and then we get the results back. It might, yeah, there we go. And if we compare the two now, you see that we are doing a slightly better job with Precision 2 than Community One. We get this beginning here correctly, and here maybe the overlapping speech is slightly better segmented. And if we compute diarization error rate on this particular example, what you see is that the legacy model would get 12% error, Community One 5.2, so huge improvement, and Precision takes us even closer to a perfect speaker diarization. And that's about it. I think I'm done on the first part of this webinar. I hand over to you, Vincent.
Thank you, Hervé. You know, the problem with people working in voice is that they talk too much. So the jokes aside, thanks a lot, and we've been having a lot of like questions and feedback from the community to just to have some more insight about the benchmark, about everything. I saw a lot of questions in the chat. Well, it would be great to go through this question just after that, but maybe just to like kickstart the next part of the session. Vivi, could you would like to share a few things about what Hervé has been sharing, and maybe it will be part of the first question more broadly about how you see Pianote with your eyes from Hugging Face and even from your users' eyes, as you just shared earlier.
I think let me start by level setting that Pianote is like critical part of a lot of pipelines today, right? Like be it via the API or be it within within individual training pipelines or inference pipelines and whatnot, right? Like there's so many packages, there's so many downstream libraries which do depend on Pionode, and kudos to you all for consistently making it better and building in public, right? Um, from what we see, like the download numbers are like through the roof, and there's a lot of community engagement, and you can see it with the most recent release as well. Like as soon as it was released, there's a huge uptick in terms of downloads and usage as well. And like if you look at the current landscape, within Hugging Face, like there's or even just within the broader community, you see that like there's always like next best thing that is coming out like every 2 days, every day and whatnot. And it's like for example, in the LLM world, yesterday there was one open source model which was the best. Today there is another one which was released, and it's the same that you see within audio as well. But for speaker diarization, like you see that pretty much you folks are like the gold standard. Like you've defended your place for years, and not just months. So kudos on that.
Thanks, and all the credit for all these years of work are for you, Hervé. It's an incredible job. Um, we've been discussing a lot about the all the our open source motion, which has been our first motion for a long time. As we shared, we are building with Hervé and with all the team, Pianot, like commercial mode, next generation mode, and more around the speaker and intelligence, I would say. From your perspective, VB, at Hugging Face, how do you see like this kind of hybrid molds are working? What do you think that, from your experience, what works, what doesn't? Please give us a sense about that, please.
Sure, I think it's like it's a typical sort of open core model, right? Like wherein like the core of your key service remains open, and I'm a strong believer of that, be it in whichever sort of like facet of machine learning models you're looking at, be it LLMs, be it text to image models, image generation models, speaker diarization, text to speech, and so on and so forth. I think like first of all, like purely from a commercial standpoint, if you have a open weights model, like users can quite easily vet the model, they can audit the model, they can try it out on their own use cases. And not just that, it is a really nice way for people to experience your model without having to lock in with you, so to speak, right? But also, what this means is that if they want more accuracy, faster inference, managed solutions, they can still reach out to you as well, right? And this is a model which I believe is here to stay. I mean, Hugging Face in itself is a good example of that, wherein a huge percentage, a significant percentage of users are using the hub for free, whilst a small percentage of our users, organizations, and so on are using it for like enterprise use cases and so on, right? I think auditability and the fact that you can just experiment with the weights is fairly important, and is going to be an even more important discussion in the discourse as we continue to sort of reach newer frontiers for these particular task types, models, and so on and so forth.
Yeah, and you've been like sharing a few things about the also the use cases behind, and that's one of our main focus, to be able to be useful in many situations. But we'll take a few minutes to talk about use cases and how we can improve how the use case we see today and the one that we are seeing as next wave of, yeah, of usage. But just before we go to that point, I see a lot of question around the performance and how we continue to improve the products. So maybe so I see a few ones about the way we improve the models. Maybe Hervé, you could tell us a bit more about. I see one from CC saying that how do we minimize the error rates and the quality of the model? Can you give us a sense of how we work on that?
So how do we do research to improve that, or?
Yeah, how we balance research, technology, and how we continue to improve the models.
Yeah, so there's no. As I said, I've been working on this particular topic for a long time now. It's definitely still not a solved problem. We have still lots of improvement to do, and as we get better and better, it's more and more difficult to actually improve. Obviously, you can't dividing the error rate by two is getting more and more difficult. So we are basically really spending some time on the research side. We're growing the research team. I would like to send kudos here to the research team because they did a marvelous work in particular on that. But we train larger model. We train with more data. Obviously, that's a bit let's say disappointing to say, but this is usually one of the key as well. Training on more data, training longer, training on. With respect to that, on training longer and more compute, I'd also would like to thank basically CNRS and because we have access to the French supercomputer. As a French company, we can actually continue making good use of this model and train, and so that's how we ended up releasing Community One, thanks to the French supercomputer. So basically, yeah, it sums up to that. Looking at spending lots of time looking at the case where we fail, trying to understand why, and coming up with new ideas on how to solve that.
Thank you, and yeah, kudos to the team working hard on building the next waves. Maybe I see a few questions about the like some tips on how to use diarization and how to use it with the ASR at the end. Maybe Hervé, could you tell us a bit more about the? So I see one of the questions we have a lot about: should we do some pre-processing stuff? How do we what would be one of the key things we should have in mind to leverage the diarization at the beginning of the pipeline? And maybe if you could also tell us a bit more about the exclusive diarization, because it's another part of the pipeline.
Yeah, so we get this question a lot, whether we should pre-process audio, for instance, to maybe remove the noise or everything. Actually, we wouldn't recommend that because our models are trained on noisy data on purpose. We actually add some more noise even on purpose so that they are robust to really noisy conditions. So it's better to actually give the raw audio to the speaker diarization pipeline really as a first step of the whole pipeline, so that you actually get the best results out of our models. And then, exclusive diarization really makes the alignment between the transcription and our diarization output easier, because then you just have to compare the timestamps. I think we just released on the documentation page of Pianot AI a tutorial on how to do that. It's for Precision 2, but it's exactly the same for Community One. You can adapt it very quickly. So yeah, I'd recommend no pre-processing, because this will add some artifacts that we've never seen during training and that will eventually degrade the performance. So yeah.
And exclusive diarization, maybe it could be another part.
Yeah. Exclusive diarization makes the alignment way easier, because then you don't have to question whether overlap and which speaker to assign a word to. Totally.
Another question we have very often is, how does switching language or bilingual conversation impact diarization?
So that's the nice part about speaker diarization. It's contrary to speech to text, where when you train a speech to text, you train it for a specific language or languages. Now there are more and more multilingual transcription models. But for speaker diarization, we are completely agnostic to the language, because those are completely orthogonal tasks. Speaker diarization focus on the speaker and has to be as independent as possible as the words that are spoken. while transcription it's the other way around. You have to be good at words and as independent from the speaker as possible. So that's how we differ between speaker diarization and transcription, and that's why the beauty of diarization is that it's multilingual by design.
Thanks. And the thing we have every day we answer this question, more or less. Um, maybe something about around the our open source models and how we, with the latest version of the model, we added some kind of telemetry in the package for the first time in the history of Pianot. So we have a few questions around that. Maybe Hervé, you can give us why we share this, why we added the telemetry, what kind of data we have, and remember share it with the people that we can everyone can actually can turn it off, obviously. And maybe if you, after that, if you maybe you can tell us a bit more about the classic way people are using telemetry and how we improve the quality of the product on the other end would be great.
Yeah, so we did add telemetry for us to get a better idea of how people use Piano open source. And mostly the idea was also to help us decide which new model to train. So that's why we are actually tracking a few things. We are tracking the duration of the audio files that are being processed, because we might want to train models for short files or for longer files. And we also track the number of speakers that are passed by the user, not the one that are automatically detected, but the one if someone actually forces the diarization to only return two speakers, and like then 50% of the requests are with two speakers, maybe we might end up training a model dedicated to two speaker conversation. And overall, as you said, Vincent, you can always deactivate this telemetry, but basically that's the duration of the file, the number of speakers when they're passed, and that's it. Basically, no personal identification ID. So yes, Vivi, I would love to know how other libraries do that, and yeah.
I think that's a very good point, right? Like we are as good as the the information we can gather before the next training run and so on, and we do this as well within Hugging Face. In fact, I think this is like a pretty common industry standard or practice at this point to sort of figure out what are the key error modes, right? Like in case there is a error, like if it's is it a user error, is it a system error, is it a specific sort of setup which is causing issues, and also more specifically, where is it that the model is doing well, where is it that the model is not doing well, and so on. So I feel like it's quite important for like startups, for researchers and so on to get this data, of course, as long as users are okay with it, right? And like within Hugging Face libraries, for example, we also have a similar way to capture what kind of pipelines are users using, what kind of models are they using, and so on. And we don't really track anything pertaining to the user itself, but it's quite nice to know like what exactly are the models or like pipelines which are being used, so that like you can prioritize the next release towards them, or you can potentially like create features to stop certain failure modes, and so on and so forth.
Makes sense. Let's be transparent here. It has been a big like decision for the company to do that. They really think that it could improve the way we can like bring value to the open source field, and we're super happy to see that many people are helping us to build it. So we've been discussing a lot about performances and how we can use the actually the well, how we use the product as an open source, but we didn't talk about much about the use cases. And I know that we are all fans of how we can serve people and help people build. Um, so maybe if you can continue about how you see, from your perspective, what you see the main like field of usage of the product as use cases, and so maybe today that's first, And from your perspective, how you see the evolution of that?
I think that's a good point, right? Like um, maybe like to take a step back. Like currently, like there are a few use cases wherein like diarization more specifically sort of comes in really handy, right? Like for example, there is real time, wherein like as like we are talking, we are able to sort of create transcriptions, we're able to do live transcriptions, we're able to identify who's talking when, right? Then of course there is the bad side of things, wherein you're processing for example YouTube videos, or you're processing videos for a particular channel and so on and so forth, and you want them to do post production on the videos, and then have like better sort of subtitles and so on and so forth. Of course, similarly, as we sort of look more forward, there is voice agents, right? Let's say that we're having this conversation, and we want to have an agent which is trying to sort of create accurate meeting notes. Then this agent needs to sort of figure out like when is Vansar talking, when is F talking, when is VB talking, and so on and so forth. Um, of course, like this is kind of like the the sort of standard way of or like the standard ways that we're seeing technology like such be used, but also like as we try to create like stronger models, like be it like foundational audio models or foundational even text models nowadays, like you require quite a lot of data to be parsed in a certain way. Like we require it to be processed in a certain way, and there as well, like you oftentimes would require diarized data, so that like the data is paired. You can then use these data sets for text to speech training, for speech training, of course, all permissive text based on whatever you're training and so on, right? And so these, and then looking sort of in the future, I see a lot more sort of real time sort of speech to speech use cases, right? Wherein like users are able to either morph speech or like translate speech, or even like summarize speech as it's happening as well. And these kind of use cases up until last year were even like unheard of, right? But now, as models are being pushed, like models are becoming compact, faster, stronger, better. We're seeing these use cases to be like much more sort of feasible as of now.
Makes super sense. And you like thanks for like sharing that. Part of the thing you said is around like new way to, well, the real-time stuff that is actually coming very fast, and there've been a lot of like commercial models that have been pushing some stuff on that field. Maybe Hervé, you can give us a sense about how we envision that as Pianot, and as from a technological standpoint, sorry, but as well where we want to move the models to. Well, I mean, for where not only on services, but I mean.
Yeah, yeah. So streaming is our number one priority. First, to get started, we really think that streaming is actually indeed the future of speakerization. We're working actively on that. It's not ready yet, but we're working very hard. So what I wanted to say is that there already exists an open source toolkit for streaming speakerization, and it happens to be the creation of our CTO, Juan. So Diart, if some of you know about that, it's actually an extension of Pianot audio open source in the streaming world, and it actually relies on the models that we trained in Community One. So yeah, streaming is really important. We will obviously, I think you mentioned that, Bibi. We ideally would like to make it run on device, obviously, everywhere conversation happens, because it completely makes sense. It might as well end up on this, which I think you know, because yeah, conversation happens everywhere, and we need a speakerization to be everywhere. And our plan really is to have the speaker diarization and streaming as good as our precision 2 model. Like excellent segmentation. It's very important to be able to detect interruptions very fast, very quick interactions, like in a, I don't know, in a police deposition. You don't want to miss a small yes or a small no, because yeah, you might miss the important information, or in defense, or this kind of stuff. So streaming everywhere, and smaller models probably, so that they can actually run everywhere.
Makes super sense. And beyond the directions itself, we have a couple of questions around how we can identify specific speakers that have been enrolled, or that kind of stuff. So we've been working on that for quite a long time, and not to have speaker one, speaker two at the end of the diarization. Maybe Eric, can you give us a sense about what we call the voice printing?
Yeah, so basically, voice printing is the task of, or speaker identification of tracking, is to track known speakers. So basically, how that would work is that you would record the voice of someone first, and once and for all, and then in subsequent conversation, you can actually tag them. For instance, for patient-doctor consultation, you might want to create a voice claim for doctors. And then you would automatically know who the patient is. If it's not the doctor, it's the patient. You don't need to actually create a voice screen for everyone in the world, but just the one that you know will use the product, for instance. And so we are working on this as well, and we actually have some features on the commercial side. But there's also lots of open source speaker embedding models that anyone can use to achieve this kind of speaker identification. So this is not part of the open source toolkit, but it's very easy to combine our speaker diarization output with a very good speaker embedding models.
Yeah, and if I may add, it's part of our vision as a company to actually continue to dig into voice, and to dig into audio, to actually bring more metadata to everyone in real time, to build on top of this data, to build voice products. Part of the products we've been discussing earlier, VB, that's really where we continue to invest, and we are actually working a lot. I'm surprised I don't see a question that I think we could have in the chat, which is, and this one is maybe for you, VB. With LLM, you can do almost everything. What's your take on LLM and speaker diarization, STT, and NTTS? What's your view on that?
Right, I think it's. I have quite a bit of controversial views on using LLMs for audio-related tasks. I think there's a. Let me start by prefacing that I think there's a lot of promise in in LLMs or LLM-like architectures for unified tasks, right? One of the examples from proprietary side that I give usually is if you look at Gemini Flash, it's a good sort of unified model which is able to do a lot of things on the surface when it comes to audio. But my sense is that a lot of these audio-based LLMs right now currently suffer from what I call the horoscope effect, which is that when you pass the audio in, it feels like it's giving you a sensible response, but in reality, it is just giving you a response which appeases to you, right? And in most cases, it would be misaligned and whatnot. At least as of now, and the kind of tech, be it proprietary, be it open, and so on, that I've seen for unified architectures, it's just not there. You see this actually also with advanced voice mode within OpenAI as well. You're talking to the same model in text, it's much more sort of smarter and crisper responses. But when you talk to it in audio, a lot is left to in the response. It's just not as good, right? So my strong belief is that cascaded sort of pipelines, wherein you have sort of audio in, you process it, you have an LLM bit, and then you have audio out, and so on, are here to stay. And there are use cases for both, right? But for by and large, when it comes to use cases which involves quite a bit of intelligence and quite a bit of sort of heavy lifting and so on, especially around agents and so on, Cascaded is probably here to stay. And I would love to find I would love for 2026 to be the a year wherein unified architecture sort of like become more useful. But yeah, that's what I would say.
That's a controversial one, actually. You're right, and not everyone is in the same bed as you are, and but we can easily align. Maybe Hervé, can you share with us what we think as pianot from that
Ye-
approach?
Yes, I mean, I'm on the team of on the cascading team, like you, mostly, maybe like the best way to actually process an audio conversation is to pre-process it with speaker diarization. This should be the first thing that we do, so that then you can only transcribe the speech tone that matters, and then only you can do something of the transcription. And while transcribing and diarizing, maybe extracting other additional features that are not in the words, like the rhythm, like the interruptions, the category of the speakers, whether they seem angry, tired, or whether they seem sick. And all of these features is difficult for an LLM to gather because it's so many completely orthogonal tasks. And so having one big model that does all of this, and maybe future will prove me wrong, but it seems very difficult to achieve. And on the particular diarization aspect, it might an LLM might actually do a good job for short two-speaker conversations. But I don't know, for very long, always on recordings with lots of speakers, there is no way that that level of viability of conversation is available in the training set of those large LLMs. So they will, and they currently are failing miserably on this kind of content. But again, maybe future will prove me wrong, but this is not the direction we are taking.
Okay, well, gentlemen, it's been an amazing first session. Thank you. We are at the end of the time. Um, it's our first. It was our first. So thank you, Vivi, for being with us for this first webinar as Pianot. And thank you everyone for joining today. Actually, it's been a real pleasure to having you with us today. A big thank you to you, Vivi and Hervé, for sharing insights and taking the time to talk about Community One, open source motion, and so on and so forth. I hope this session, and we hope this session, helped you better understand what speaker diarization is and what we are doing. And then, actually, as a reminder, you will receive the replay of the session shortly by email, so you can take a look at it after that. If you didn't have a chance to ask your question live, feel free to reach out to us directly via our Discord community that we launched. So you saw a couple of QR codes on the presentation. And we really hope that we see you again for our next session in a few weeks. Thanks again, everyone, and see you for next time.
Thank you.
Thank
See
you.
you. Thank you.